Hey guys, thanks for visiting my YouTube channel. Today in the workshop we have an auxiliary power unit from a Tristar jet airplane. So we have here an ST6L-73 auxiliary power unit. This was built by the Hamilton Standard Company, a division of United Technologies, and it's actually derived from the very common Pratt & Whitney PT6 turboprop engine. So this is a two-shaft gas turbine. It's rated at about 630 horsepower, and it is used as an auxiliary power unit on board the jet airliner. It has a number of functions, including supplying compressed air and electricity for aircraft services. So let's have a closer look. So here it is. This is the front of the engine, and at the front we have the accessory gearbox, which has a number of devices fastened to it, including the starter motor here. This unit here is the ignition system, and we also have the oil pumps, and around here is the fuel control system. So this engine, a two-shaft engine, was derived from the PT6A turboshaft propeller turboprop aircraft engine. It's been modified and adapted for use as an auxiliary power unit. So this area here is the air intake area. This large box forms an air intake plenum, which allows the engine to consume large volumes of air, and underneath we can see the air intake ducting. So this unit, when installed in the aircraft, was actually mounted towards the tail area on the underside, and it's actually carried upon a piece of airframe, this structure here, and this was fitted up into the back of the aircraft. It was also mounted at an angle of about 25 degrees, so you can see that currently this engine is not actually sitting at the correct orientation. For actually operating this engine, it needs to be adjusted so that it is orientated as it would have been in the aircraft. So carrying on down, there's the main body of the engine. This is the combustion chamber. This engine is a reverse flow combustion chamber, and in the centre of that is the compressor, and it consists of a centrifugal compressor and a number of axial stages. There is then a turbine mounted about here which drives the compressor. So it's a two-shaft engine, so it also has a free turbine mounted about here, and then that drives a number of mechanical loads. And these loads consist of three different things. We have a air blower here, supplying air to a number of coolers. And if we look down there, we can see that's an oil cooler radiator. The main load placed upon the engine is this, the socking great big compressor. So this is a single stage centrifugal compressor driven by the free turbine of this engine. And if we look down here, and if I turn these blades, you can see inside there, that is the impeller, compressor impeller, and that's the main function of this engine, is to drive that compressor, and it discharges air through this duct here, which would be used for starting the main engines on board the aircraft and also for air conditioning. This engine has a number of special features. This thing here is a type of throttle, so it varies the amount of air that the engine is drawing in, and is able to adapt it for different air loads, so that it operates at less power when not called upon to start the engines. Carrying on around here, we see the alternator. This is a 400 cycle 3-phase alternator. This spins at 12,000 RPM, and it produces up to 90 kilowatts. It's also oil cooled, and oil travels in some pipes to the cooler on the other side of the engine. There's a number of other things here. There's some ducting. That is an air bypass which discharges into the exhaust, and this pipe work here controls the operation of this compressor and adapts it for different loads. Moving on around, there's some various filters there, and if we come back round to the front of the engine, there are more bits and pieces. That is a fuel oil heat exchanger. There is a cap here for filling the engine with oil, and down here there are some devices for instrumentation and control. So that unit there is the tachometer generator for supplying a cockpit speed indicator. This engine is actually electrically or electronically controlled. It has remnants of the propeller turboprop version, but in addition to that, it has an external electronically controlled governing system, and the speed of the engine is actually, and the fuel flow through the engine is varied by a special valve there under electronic control. So that's mostly it. It's a twin shaft engine, quite unusual for an auxiliary power unit. Most auxiliary power units are a single shaft design. It's very old. It dates back to the 1970s. But it's in fact a very common and very successful engine in its turbo propeller form. The PT6A is a very successful sort of medium-size twin shaft gas turbine engine. So there we are, a brief introduction to the Tristar auxiliary power unit. I hope you enjoyed it. So I forgot to mention, this engine can be seen running on my YouTube channel. If you search for L1011 APU, you should be able to find a video taken from a few years ago where we test run this engine.